There are two main types of weathering. There's physical and chemical weathering. Weathering is the process that breaks down rocks and dissolves them into smaller rocks and particles. The broken rock, the broken up rock is called regolith. Physical weathering occurs when there are no chemical reactions that aid the breakdown of rocks. There are three main types of physical weathering. There is frost action, crystallization, and pressure release jointing. Frost action occurs from the freezing and thawing of water. Water seeps into the cracks in the bedrock, and when the temperature drops, the water freezes and expands. When the water freezes and expands, it pushes outward on the rock, slowly separating this rock. Over time, this continued freezing and thawing will force the rock to split apart. A similar process to frost action, crystallization also forms from water. The water again seeps into cracks in the bedrock, except instead of freezing and thawing, the water evaporates and leaves behind salt crystals. This continued evaporation of water in the cracks leaves behind salt deposits. As more and more salt crystals fill the crack widens and the rock eventually breaks apart. This process happens at a much slower pace than frost action. The final form of physical weathering happens with pressure release jointing. The rock underneath the surface has forces compressing it from the sides, and there is an equal force pushing back on these forces from the rock. When the outside forces to the rock stop exerting this pressure on the rock still has the force pushing outward. Loss of the shear strength on the outside causes the rock to spread apart, creating cracks in the rock. This rock will eventually separate and split apart. The next form of weathering is chemical weathering. Chemical weathering occurs through the chemical breakdown of rock when minerals combine and react with water. Chemical weathering can also happen in three main ways. It can happen through hydration or hydrolysis, oxidation, and through the dissolution of carbonates. Hydration is the process of water combining with minerals. When minerals react with water, it can break down the surrounding rock by expanding and pushing outward force on the rock, forcing the rock to separate. Hydrolysis involves the chemical reactions of water and minerals. When hydrolysis changes the rock, the mineral breaks down and causes the rocks to fail and disintegrate. The edges of the rock become rounded from the breakdown. The next form of chemical weathering is oxidation. All of us have seen oxidation, even if we don't know it. Oxidation is the process of metallic elements combining with oxygen, forming oxides. It is a chemical change of water and salt. We see oxidation happen to many vehicles. In winter, your car picks up the salt and water from the roads. The water evaporates, leaving the salt behind on your car. When that salt reacts with the oxygen in the air, rust occurs and leaves a brownish stain on your car. This is a process of oxidation. The last form of chemical weathering is the dissolution of carbonates. This occurs when the rain falls to the ground and runs through the soil. When it goes through the soil, it dissolves carbon dioxide, forming carbonic acid. This now acidic water dissolves calcium in the ground. The acidic water dissolves the limestone and marble because of their high calcium content. The process through which limestone breaks down through chemical weathering is known as karst topography. There are four main things that need to happen to form karst. First, the limestone must contain at least 80% calcium carbonate. Then, complex forms of joints must form drainage channels. Next, there must be an aerated zone between the surface and the water table. And lastly, vegetation cover is required to supply organic acids that aid the dissolution process. The rainwater percolates through the soil and then reacts and dissolves carbon dioxide, forming carbonic acids. This acidic water also percolates through the cracks in the rock below and eventually goes into the water table. If there is an aerated zone beneath the surface, such as a cave or cavern, the dissolution of carbonates will continue to grow through this aerated space, larger and larger. When the aerated zone becomes so big that the bedrock above it can no longer support the soil and the surface and soil fall, creating a hole in the surface. This hole is what we call a sinkhole, and this process is how sinkholes develop. There is also differential weathering between rocks. This is when rocks weather at different rates. This process is responsible for some of the most scenic landforms in the world. Many of the famous arches, such as the Delicate Arch in Arches National Park in Utah, have formed through differential weathering. At one point there is large and numerous rocks above the surface. When weathering agents such as wind, water, and erosion affect the rock, most of the rocks will disappear. The rock that is left behind is the more resistant rock. The rock left behind is more resistant to the weathering processes than the rock once surrounding it. Many times this is because the, the remaining rock has hard caprock